Welcome back to Chem 330. So far in the material we've learned new concepts every time we have come back to it. We've learned that alkanes have a general formula of CnH2n plus 2, right? And we learned alkenes have CnH2n, and then we had alkynes which are CnH2n minus 2. Okay, now we know that alkanes have only single bonds, alkenes have single and double bonds, okay, and alkynes have single and triple bonds. Now there's another class of compounds called cycloalkanes. Even though it's got the word alkane as a last name, it does have double bond properties. Okay, that's very unique, right? Well, if you say alkanes, it should only have single bonds, right? Yes, the compound itself does not contain double bonds, but it has properties of a double bond. Now, what did I say before we get started on this? When I told you, when I drew the line structures, right? I said the terminal is always CH3, right? This is always going to be CH3. And I said this is always CH2, right? This bend right here is always CH2. So every time you see a bend, but on the other hand, I did also tell you that if a bond is sticking out, then this is CH3. This bend is no longer CH2, but it's CH, right? That was in week 3 videos. If you're still not sure, you have to go watch it and have your questions addressed in class, right? Now cycloalkanes have only single bond, but they have properties of a double bond. All right, so let's go look at it. All right, so let's go watch it again. So cycloalkanes, okay, also have a general formula of CnH2n plus 2. Okay, I don't think I wrote my cycloalkanes very well. It looks almost like a cycloalkene. It's a cycloalkanes. Okay, cycloalkanes. Okay, sorry, it should also have CnH2n formula. Okay, that is, if I have C5, I should have 10 hydrogens. If I have 6 carbons, I should have 12 hydrogens. So if I ask this question on the test and I have you write isomers for say C5H10, there's 2 ways you can do. You can do combinations as well. So 5, we know that this is an alkene, so it has a double bond, right? So it will be CH3, CH2, CH2, CH double bond CH2. That's one of the isomers. Or it could be CH2, CH double bond CH. And some of you are still making the mistakes of, even though your skeletal structures might be right, you still can't get credit because you're off by your hydrogens. Okay, some of you are still writing CH2 here, or you're missing out the hydrogens completely. Well, when you finish constructing any structure, your carbons and hydrogens must tally up. If it doesn't, then we have a problem, right? Now we can keep writing more isomers for C5H10, right? But then we can also have it as a cycloalkane, right? Cyclo means it's cyclic, it's a loop. Okay, that means we have 5 carbons, right, that are connected in a ring. We have a C5H10, right? So that means each carbon now has 2 hydrogens. Remember, carbon cannot have more than 4 bonds, right? So each carbon is connected to another carbon by 2 bonds, but then each carbon is also connected to 2 hydrogens. If you count, this is also C5H10, which is why it's called cycloalkane, because if you noticed, it's got all single bonds, right? So does it mean it has sp3, sp2, or sp hybridization? What do you think it's got? Think about it. It's got sp3, sp2, or sp. Think about it. Well, I've already given the clue. The last name for these type of molecules is called alkanes. But because it is cyclic, it also contains double bond properties. Okay, but the carbon itself, you have to tell me in class whether that's sp3, sp2, or sp hybridization. We'll come back to this maybe later. I can address it specifically what that is. But this is just a pop quiz because I have taught you how to figure out hybridization for a carbon based on whether it's got single, double, or triple bonds, right? So keep in mind, this is also an answer that you can write for your isomers if you're running out of options. But again, you can only write one of these, okay? There is no alternate versions of a cycle. That's what this is, okay? So another class of compound is, so you can have cyclopropane, okay? That is C3. Well, how many hydrogens? Well, we do know cycloalkanes also have C and H2N, right? So C3 means it's 6, right? So cyclobutane means C4H8. So cyclopentane, okay? Cyclopentane is C5H10, and cyclohexane, which is a compound that leads to a lot of confusion to some of you down the road, C6H12, right? Now, looking at this and using your knowledge of sp3 and sp2, okay, this is a cyclohexane. Keep in mind, this is a bend, so every bend is a CH2. If you forgot what it would look like, well, keep in mind every carbon is attached to every other carbon, but then each carbon also contains hydrogen. Now again, you don't need to memorize it. I've always told you, if it's a bend, that means that bend is a CH2. So there's no doubts about it, right? And what did I say when I talked about whether a molecule is planar or not planar? If you have alternate single double in the entire molecule, then it is, if you think about it, that compound only contains sp2 hybridized carbons, then we said that's planar, okay? If it contains single, we said it's not planar, okay? If it contains single, triple, all the way, we said it's linear, right? This is sp, this is sp3, this is sp2, right? So would you say that is this carbon sp3, sp2, or sp? I asked this question on the previous grain with the cyclopentane. Think about it, okay? And I can give you the answer. This is not planar. Maybe that will help you narrow down your choices. Well, clearly there is no double bond anywhere in this molecule, right? And then there is also no triple bond. So what do you think is the hybridization here? sp3 or sp2 or sp? Okay, it's not planar. I've already given you the answer. Okay, I can't give any more than that. That's, again, this is not a quiz, but this is the way you want to remember things. Okay, because the reason I say why people get confused is down the road you would learn a compound called benzene, which would look like this. Okay, with alternate single and double bonds, and I think I even mentioned this in one of the worksheets we did in class. I gave you this image. Okay, this is benzene. Now the compound we talked on the previous slide does not have a double bond. This is cyclohexane. They're not the same because they kind of look, has that hexagon ring, does not make this and this the same. This we said it's all sp2 hybridization, right? Because we have single double. So we said this is planar. There is no double bonds at all, and this is all sp3 hybridized, right? sp3 hybridized, right? And it's all single bonds. So this is not planar, right? So please do not confuse cyclohexane and benzene now or in the future. Then you're going to have a serious problem in your hand because they're not the same and they don't have same properties. Benzene is planar, means it can sit on the plane of the molecule. Even if your molecule contains at least one sp3 hybridized carbon, that means carbon containing all single bonds, that whole molecule becomes not planar. That's not the case with benzene. Okay, now because people write this cyclohexane in this format, it leads to more confusion. But technically this is the way we write it, but technically this is how it looks like. Okay, this is gonna take some getting used to, okay? This is a chair conformation. This also exists in another conformation, means it's just a shape of it, okay? A molecule can exist in more than one shape, okay? You see, this is also C6H12, okay? This is also C6H12. This is boat conformation. This is a chair conformation. Chair conformation is more stable. Now some of you would be more comfortable to draw it this way. Some of you might find it easier to draw it this way. They're both chair, okay? Looks like one of your pool chairs. That's what it looks like. I don't care which type of chair you want to draw, but make sure it does look like a chair, okay? I mean, this I could have drawn it a little straighter, but again, that's all cosmetic. As long as you have one of the two chair conformations. So this maybe we draw it this way, but this is not how it looks. Benzene, on the other hand, looks just like the way it's drawn. Cyclohexane does not look like the way it's drawn. It exists in at least two basic conformations. These two are identical because they're both chair, okay? Identical. You can pick which one. I know naturally some of you will be able to draw this all the time. Some of you would be able to draw this naturally all the time. That's just the way it is. But you may have be sometimes will be forced to write one of this depending on the question. But then there's a boat that looks easy, right? So this is how this compound exists. Like, it does not exist like the way it's drawn on the paper, which may give you the impression that it is planar, but it is not, okay? So cyclohexane, I don't think any of the cyclic ones are planar because they all have sp3 hybridization, which means they're all non-planar. Means when you put this molecule on a piece of paper, if you can, which I don't think how you will, but let's say you take it and put it on a piece of paper, you will stick out of the paper because every carbon is sp3. This, on the other hand, benzene, if you take it and put it on a piece of paper, it will stay on the plane of the paper. That's what we mean by planar and not planar. Okay, now boat conformation is less stable. We don't want to go too deep into that, and chair conformation is more stable of the two. Doesn't matter which form of chair you write, they're both more stable over a boat conformation. What the word is conformation, that's what I've been using. Conformation means multiple shapes of it, like a triangle, square, rhombus, octagon, hexagon. These are different shapes. These are different shapes. A boat is less stable, a chair is more stable. All right, now stay tuned. I'm going to walk you through something that's very, very important in the next video. All right, stay tuned.